With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Highly excited states for hydrogen-like atoms, also called Ryburg states with nucleus charge Ze, are defined by their principal quantum number n, where n is very smaller than 1. Which of the following statements is true? So the first statement is relative change in the radii of two consecutive orbitals does not depend on z. So the radii is given by Rn is equal to 0.529 n square by z. So if we are talking about the relative change in the radii of two consecutive orbitals, so let's say first orbital is n and the second will be Rn plus 1, that is 0.529 n plus 1 square divided by z. So as we can clearly see that only the value of n is changing between two consecutive orbitals. So therefore the change in the value of radius will only be attributed to the change in the value of n and not on the value of z. So the first statement is a correct statement. The second statement says relative change in radii of two consecutive orbitals varies as 1 by n. So we already have the radii of nth and n plus 1th orbital. So the change in the radii of two consecutive, that is delta r, is equal to Rn plus 1 minus Rn, which is equal to 0.529 by z times n plus 1 squared minus n squared, which is equal to 0.529 by z 2n plus 1. It talks about the relative change. So relative change will be delta Rn upon Rn, which is equal to, since 0.529 by z are common in the expression for Rn and delta r, so they will get cancelled out. So we are left with 2n plus 1 by n square is equal to 2 by n plus 1 by n square. And since it says that n is very smaller than 1, so this term can be neglected and we are left with 2 by n. Therefore the relative change in the radii of two consecutive orbitals varies as 1 by n. So this statement is correct as well. The third statement talks about the relative change in the energy of two consecutive orbitals. Energy in nth orbital is given by En is equal to minus 13.6 z squared by n squared. So En plus 1 will be minus 13.6 z squared upon n plus 1 squared. Now they are talking about the relative change in the energy of two consecutive orbitals. So let's say delta E will be equal to En plus 1 minus En, which is equal to minus 13.6 times z square upon 1 by n plus 1 squared minus 1 by n squared, which is equal to 13.6 z square 2n plus 1 upon n plus 1 squared n squared. And the relative change therefore will be delta E upon En. So the 13.6 and z square are constant terms, they will get cancelled out and we are left with 2n plus 1 upon n plus 1 squared z squared into 1 upon En, and En is 1 by n square, so 1 by n square. Sorry, this should be n square. So n square and n square get cancelled and we are left with 2n plus 1 upon n plus 1 squared which can be written as 2n plus 1 upon 1 plus 1 by n squared, and since n is very very smaller than 1, so 1 by n tends to 0, which means 2n plus 1 upon n square, which becomes squared, which becomes 2 by n square, 2 by n plus 1 by n squared, which becomes 2 by n. So the relative change in energy of two consecutive energy states is dependent on 1 by n, whereas the option says that it should vary as 1 by n square, so option C is incorrect. Now the final statement says that relative change in angular momenta of two consecutive orbitals varies as 1 by n. So the angular momentum for nth orbital is given by nh, which means for n plus 1 it will be n plus 1 h. Change in angular momentum becomes n plus 1 minus n times h, which is equal to h, and the relative change becomes change in angular momentum divided by angular momentum for nth orbital, which is h upon nh is equal to 1 by n. So the relative change in angular momentum varies by the factor of 1 by n. So the final statement, D statement, is also correct. So the answers for this question are A, B and D.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.